All right, let's take a minute to look at the Lab2, Micro800 Lab2, and there was definitely some well, I guess confusion, perhaps, which is completely understandable, starting out around the stop push button. And of course, in the lab instructions, I had actually had a circuit drawn up for you to program, and it showed putting the normally closed contact for the stop button, and it wound up not working. And the reason for that was because the actual real push button that you wired to the PLC, the stop button was actually a normally closed contact to begin with. So when the lab instructions were kind of originally documented and built up, it was under an assumption that both the start and the stop push button would have been a normally open contact. But in reality, the push button station that you had available to you had a normally open contact for the start and a normally closed contact for the stop, right? So in the real world, we get curveballs thrown at us all the time. So let's just walk through the basics of that, hopefully to help you visualize this maybe a little bit better. So on the screen, I have a virtual push button station, but it will act exactly as if it was the real push button station that's in the lab. There's a start button and a stop button. The start button is a normally open contact, and it is animated right now. And right now, this is not filled in green, so I'm not pushing the start button. So therefore, it is not. This contact is open and is not passing power, so to speak. Right? I have 24 volt DC coming into the push button, and then only when I push it will the contact close and let 24 volt power pass through. In the lab, the start push button was wired directly to the PLC. So if I come over here to my Micro800 simulator, this is the other piece that I'm going to use just to demonstrate this. The same connected components Workbench software, or CCW software, has a ability to run a simulator. So I don't actually have to have a real PLC in front of me. So right now, this is exactly the setup that you had last night. You see no input on input 0, 0, and you see input 0, 1 as being on. And we can also see it right here in the little LEDs, just like your real controller had 0, 1, 2, 3. We see that 0 is off and 1 is on, right? And that's because the stop push button is actually a normally closed contact, meaning that when I'm not pushing it, the contact is actually closed. It is letting 24 volt DC power flow through and go to the next part of the circuit, which in this case, it was simply wired directly to the PLC. All right, so just go with me that this is our real push button, and this is our real controller, and then this is our software in the background that we'll be able to look at what's going on. The other thing we didn't look at last night was to help visualize this before I go into the logic, is the variable table. So I actually am connected to the controller right now, and I'm looking at the status. The logical value column is basically if the input is on or off. So you see this blue checkbox right here. The blue checkbox on DI01, which is the stop pump alias, is showing as checked blue and therefore showing as on. And it, of course, is showing as on here on the simulator. And over here, it's actually showing as on, right? Because I got a red indicator, and I actually have this animated red right now. So this push button, of course, I'm not pushing it. It is closed. Now, I want you to pay attention to quite a few things here when I push this button. This will turn off, this will turn off, and this will turn off. So I'm going to go ahead and push the stop button. I'm going to hold it down because it is momentary. If I take my finger off of it, it will kind of change back. So I'm going to push the stop button, hold it down. We see that the logical value went to off. The actual input went to off, right? So that's not orange any longer, and the 1 is not orange any longer. This is no longer solid red, and this actually went back to black. Now, the minute I take my finger back off this button, the contact closes, since it's normally closed. That came on again, the input came on, that turned orange, and that turned orange, right? So basically, when we first, kind of wrote the code for this lab, we made an assumption, right? Without really knowing any better, we made an assumption that both the start push button and the stop push button would be normally open. Now, let me go ahead and demonstrate when I push the start button here. If I push the start button, you'll see that this will turn green, this will turn solid green. You'll see this logical value here turn to blue with a checkbox, and you'll also see the 0, 0 input turn orange, both here and on the numbers down here. So I'm going to go ahead and push the start button. I'm going to press it and hold it for a second, right? Because it is a momentary push button. If I take my finger off it, you see that it does drop out. So I'm going to push the green button again, hold it for a second. We can see that the the logical value for start pump is blue and checked. We see the 0, 0 lit up here as well, right? So I'm going to take my finger off the button and it goes back off, right? So normally open contact, such as start, right now there's no power on it. This contact is open, and then when I activate it or press it, then the contact closes and power passes into the PLC. That's what we kind of use the term passing power, because it's allowing power to flow through it. Normally closed contact, of course, it acts in the exact opposite manner. It's always closed. It's always passing power until I actually actuate it and press it. So now I'm going to press stop, and we see that it changes its state. Now it actually opens versus being closed. All right. So now let's go into the actual logic. And let me get my simulator back up here as well. So this was the program I had you originally create, right? And again, the assumption being was that the stop button was going to be a normally open contact. So in our logic here, we have the start pump contact as a normally open, and then we had the stop pump contact as a normally closed, and then we had the pump starter coil, which would basically be an output, and then that same pump starter coil contact was going to be used in parallel to latch in or seal in around the start push button. Now, you can see right now that this is not animated as a different color. Now, I went ahead and changed the color of my editing software here to show up as red, because it was a little hard to see the green with the blue line and the yellow background. So I went ahead and changed it to red to make it stand out a little bit more. So I'm pressing the start button, and we can see that that means that this contact has changed state and is now passing power. Basically, this would be a 1. Essentially, this is a digital 1. It would be letting power flow through to the next element of the rung. But you can see that the stop is not animated as red, and that's because it's already on right now, and I use a normally closed contact. So just like over here in the real world, the physical button, normally closed means that when it's a 0 or an off, it's actually on. It's like an inverter, right? And then when I press it, it would actually be off. So when I press it, make it into like a 1, so to speak, it becomes off. Now, that's the same thing's happening here, right? So we're kind of reversing it here, and then we're actually reversing it back again a second time with this one. So right now, the PLC is showing it as a 1, and at a normally closed contact, if it's a 1 or on, then it will be open or off, right? Because it's the opposite. When it's on, when the bit is showing as a 1, then in reality this is going to open and be off. And then when this is showing as off, then this would be on or a 1. So if I were to push the stop button right now, you're going to see this go red. Right? Oops, there it goes. So so basically now when I'm pressing the button and actually opening the contact on the physical button, now it's letting me kind of pass power in the program. Okay, so we kind of had a double negative thing happening here, right? We had the physical push button kind of reversing reversing it, and then we reverse it again in the program, right? So two wrongs here, so to speak, don't make a right. So what we need to do to fix this situation is, being that we now know that this push button is wired differently from what we first assumed, we really have two options. One, we can get a different push button that actually would be normally open, that would make this happy. Or the easier solution, being that we're programming this, is that we could just reverse this contact in the program and not have to rewire anything out here in the physical real world. So I'm going to pause for a second, and I'm going to change our program, and we'll pick back up in just a moment. All right, I'm back. I've reconfigured my program. Basically, all I did was change this stop pump contact to be a normally open or a direct acting contact. The terminology in the CCW software is direct contact or reverse contact. We could also call it normally open, normally closed. The terminology, gets kind of twisted and turned all about throughout the industry, but basically it was normally closed or reverse acting, and now I put it back. Now I changed it to a direct acting or normally open contact. Now I just need to kind of reset my simulator. That's why I wasn't showing red there. So basically, now this is exactly what we would expect. This is what we had last night in the lab, right? Once again, we had a start button wired through a normally open contact into the PLC, input 00. It is currently showing as off, so I'm not pressing it. I had a stop button wired through a normally closed contact going to the PLC, and it is showing as on at the PLC. 24 volts is basically flowing through and going into terminal into input 01 on the PLC. So it is showing it as an on, right? So I have an orange light on input 1. Now, because of that, since input 1 is on, this is a normally open contact now, so therefore it is showing on. And the reason again for this is because we had to have a logical flow from across the rung in order to get to the pump starter, right? I had to have the start pump has to be true, and the stop pump also has to be true. Since they're in series with each other, those two have to be on, essentially, passing power in order to have power flow to the coil on the right-hand side of the rung. Right, so if I were to push the stop button, you will see that now it opens in the program. And I took my finger off the stop button. So after all that, I'm going to go ahead and push the start button. Take my finger off the start button, and now we have what we were expecting to see. I was able to start the pump. The pump has latched in on itself. I used the pump starter contact right off this coil. to latch in around the push button. It is going through the stop push button and keeping this relay or this coil energized. You can see down here on the outputs, 0, 0 and 0, 1 are both turned on. 0, 1 is right here because I just have another contact that basically said, hey, turn on a light to show the pump is running, perhaps, right? This would be the contactor that would start the motor. Rung 2 would be like a light or an indicator that would show us that it is actually running. So I just have 2 rungs for that. Now, if I were to push the stop button, it will change state, break the latch. And if I take my finger off the stop button, then it's basically reset and ready to go for the next time. All right. So admittedly, kind of confusing to start out with, but you just got to kind of remember what's happening with this, right? We have the physical contacts out here at the push button station. How do they behave? Normally open versus normally closed. And then we need to use the contact in the program to basically based on whatever conditions we need. Like for instance, if we're going to actuate it in order to turn it on, such as the start button, right? We're going to use normally open, but we're going to be pushing the start button. And in this case, we had to kind of reverse our logic for the stop button. As we do more exercises like this, it'll start to gel more for sure, but hopefully taking a few minutes here to explain this kind of helped you out.